So under solubility equilibria, I want us to first define what we call solubility. That is something I want us to first define. And this is defined as the mass of maximum mass of a solute in grams. That mass should be in grams. That can saturate 1,000 grams of a solvent at a particular temperature, so long as there is some undissolved solute that is in excess in that solvent. So we are saying this is the maximum mass of solute in grams that can saturate 1,000 grams of a solvent at a particular temperature. But there must be, in the same solution, there must be an excess of undissolved solute. I don't know whether you're getting me. So what are the key points here? Maximum mass of a solute in grams that can saturate 1,000 grams of a solvent at a particular temperature in the presence of some excess undissolved solute. The units of solubility are grams per 100 grams of solvent. This is not 1,000, it should be 100. Sorry for that. This should be 100 grams. We are going later to distinguish between what we call solubility and molar solubility. So units are grams per 100 grams. So these grams are for the solute per 100 grams of the what? Of the solvent. Or it can be written as grams, then 100 grams per. These two mean the same thing. What is the key point? What's the meaning of this definition? If I'm to go ahead, let me assume I have my container. In my container, I have 1,000 centimeters cubed of water. The 1,000 centimeters cubed of water, since volume is mass times mass is volume times density, volume of water here is 1,000 times the density of water, which is, what is the density of water? It is 1 gram per cubic centimeter. So if I multiply that, I get the mass of water, meaning that the mass of this same water here should be 1,000 grams. Now, if I add sugar in here, as I stir, a point is reached when no more sugar can dissolve at a given temperature. Let's say it's the room temperature, which is 25. At that temperature, when you dissolve a given mass of sugar in this water, such that no more of the sugar can dissolve. In other words, when you form a saturated solution, and then you reach a point when there is an excess of sugar at the bottom here, even if you stir, it cannot dissolve. That mass of sugar that would have dissolved at that temperature, at that particular point, is what we call the solubility of sugar in water. Let's assume that mass of sugar is around 356 or 58 grams. So the solubility of water can be written as 358 per 1,000 grams of water at 25 degrees Celsius. Are you getting me? Hopefully you're getting the point right. Now, there is what we call, that has been solubility. We have seen solubility by definition as the maximum mass of solute in grams that can saturate 1,000 grams of water, not particularly water, but any solvent at a given temperature. I assume the temperature is 25 in the presence of some excess and dissolve the solute. Now there is what we call molar solubility. Is what we call molar solubility. What is molar solubility? We are only adding one word, molar, to the term solubility. So the word molar comes from the word moles. And therefore our definition would be the number of moles of solute. Molar solubility is the number of moles of solute. It's not now, not mass now. That can dissolve in 1 liter of a solution before that solution becomes saturated. Before that solution becomes saturated. Okay? Number of moles of solute that can dissolve in 1 liter of solution before that solution becomes saturated. That's what we call molar solubility. So the key points here are number of moles of the solute that can dissolve in 1 liter of a solution before that solution becomes saturated. So for this one, the units are always moles per liter, or capital M. And it's the solubility that we shall be using in most of our calculations, the molar solubility. Are we together?
Yes, teacher.
All right. Now we are aware that there are some soluble salts. In terms of solubility, there are soluble salts, and they are what we call sparingly soluble salts. In the real sense, or in a common understanding, those are the 2 types of salts in terms of solubility that we have. There isn't an insoluble salt. That's not true. We cannot say a salt is completely insoluble in water. At one point, there should be some component of that salt that is dissolving in water. So the most important term here to use is sparingly soluble salts. We shall see these ones later. For now, I want to examine these soluble salts. Can you give me examples of salts that you are aware are soluble, completely soluble in water?
Sodium chloride.
Sodium chloride, that one is completely soluble in water, and its counterpart, potassium chloride. I can give you one, there is ammonium chloride. Any other? Ammonium sulfate, ammonium nitrate. In other words, all sorts of sodium, potassium, ammonium. Which other ones?
Nitrates.
All nitrates, all chlorides, apart from lead 2 chloride. Apart from lead 2 chloride, silver chloride, and others. Then all sulfates apart from barium sulfate, lead 2 sulfate, silver sulfate, and others are soluble in water. So these soluble salts here, we cannot say they are sparingly soluble. For them, they are completely soluble in water. And for them, right now, I want to take you to an experiment that we can use to determine their solubility. Experiment to determine solubility. Give me one of them that we should use to determine its solubility. This is not a common experiment, but we need to understand it. Can we determine the solubility of maybe, which one of those ones can we use? Any soluble salt. Let's use maybe ammonium chloride. We want to describe an experiment to determine its solubility in water. So what shall we do? We shall get our beaker. This is the beaker or any other container. We put there a known volume of water, b centimeters cubed of water. So if that's our container with a known volume, b centimeters cubed of water, we are going to add there ammonium chloride, our soluble salt, a little at a time. Muhammad, are you getting me?
Yes, teacher.
We add a little ammonium chloride at a time while stirring. We add a little ammonium chloride at a time while stirring. This known volume of water must be immersed in a thermostat. What's the purpose of the thermostat? To maintain a constant temperature. Remember, we said solubility must occur at a particular temperature. I must keep the temperature constant. So we add a liter at a time and while stirring until no more of the ammonium chloride dissolves. Are we together? So when no more ammonium chloride dissolves, we have formed what we call a saturated solution. So when you dissolve until no more ammonium chloride dissolves, allow the mixture to settle. Why do we allow it to settle? For the excess and of the ammonium chloride to settle at the bottom of the beaker. Okay? Then what do you do next? What do you think we shall do next? Who can guess?
We will filter.
Perfect. We filter. On filtering, we are obtaining a very good solution. Which solution is that? We call it a saturated solution of ammonium chloride. On filtering, we obtain a saturated solution of ammonium chloride. Now you get a thermometer and record the temperature of that solution. The saturated solution you have obtained, record its temperature from a thermometer and record it as T1 degrees Celsius. So after recording it as 1 degrees Celsius, you get a dish now. That's our next step. Get an empty dish. That dish you measure its mass. You can call that dish, but the mass may be, can call its mass may be A grams. That's our empty dish. You power there a known volume of the saturated solution you have filtered. Remember, you have obtained a very good volume of a known of the saturated solution. Get a little amount of it and power it on your dish. Okay. Now you weigh the mass of now the dish and the solution. You can record that mass as B in grams. Now you place this on a steam bath. Place it on a steam bath. What's the purpose of the steam bath? You are going to evaporate the mixture until you obtain dry ammonium chloride crystals. The procedure is a bit long, but understandable. When you obtain the dry ammonium chloride crystals, you're going to allow the dish and its contents to cool. And then weigh the mass of the dish and the dry salt again. That mass you are going to call it C grams. Okay? Let me hope you have understood the procedure up to this point. This procedure is a bit long, but understandable. It's a procedure to determine solubility of a soluble salt. Any soluble salt is the same procedure. Is there anyone who can repeat for me the procedure up to now? Or I proceed, you've understood? Muhammad, can I proceed?
Yes, teacher.
How about Raymond?
Yes, Jay, you can proceed.
Okay. Now we come to our treatment of results. Treatment of results. That has been the procedure. We want to treat those results so that we get the solubility. So what shall we do? Remember, we have the mass of the dish. Our mass of the dish was 8 grams. When we added the dish plus a saturated solution of potassium nitrate, we added the mass of dish plus saturated solution of ammonium chloride. That mass there was B grams. After evaporating to dryness, we got the mass of dish plus dry ammonium chloride. That mass there was 6 grams. We had the temperature at which we carried out the experiment. Temperature of the saturated solution as T degrees Celsius. What will be our mass of the saturated solution? Mass of saturated solution will be mass of the dish plus the saturated solution minus mass of the dish alone, which is B minus A grams. Then mass of the dry ammonium chloride will now be this mass here, mass of dish plus dry ammonium chloride minus mass of the dish. So we go back to the definition of solubility, which is mass of a solute that can saturate 1,000 grams of the solvent. Now we need to get the mass of the water that was present in the saturated solution. That one is got from these two here. This is the dry ammonium chloride. This is the saturated solution. So to get the mass of water that evaporated when we were drying this mixture is to get this mass here minus this one. Hope you're getting me there. Is that point clear? Most of people get confused at this point. This was our saturated solution before evaporation in the steam bath. This is the mass of the ammonium chloride that is dry. So to get the mass of the water will be that value there, which will be C minus A minus B plus A, which gives us C minus B grams. That's the mass of water. Are we together? Can I proceed?
Yes, teacher.
All right. Now we want to get the solubility. We shall say the C minus B grams of water dissolve which mass of the ammonium chloride? Which mass of the ammonium chloride? This is the mass here, the one of dry ammonium chloride, C minus A. It will dissolve C minus A grams of ammonium chloride at T degrees Celsius. How about 1,000 grams of water? You now bring out the definition of solubility. Not 1,000, but should be 100. Remember the definition very well. How about 100 grams of water? This one will dissolve 100 into C minus A, we are cross multiplying, over C minus B grams of ammonium chloride, such that our solubility is equal to 100 into C minus A over C minus B grams per 100 grams of water at T degrees Celsius. Can I assume everything is fine up to that point? Is there anything that's not clear that I should emphasize? Yeah, in case you have a question, you can type it there or raise up your hand. Everything is clear up to that point. I can now proceed to factors that affect solubility of a soluble salt.